Welcome to The Explainer. Today, we're pulling back the curtain on one of the most important concepts in all of computing, caching. It's the secret ingredient, the clever trick that makes your phone, your tablet, your computer, all of it feel fast and snappy.
But let's be real. You've probably had this feeling, right? You get a brand new machine, it's got the latest processor, tons of memory, and yet, sometimes it just lags. It's frustrating, but you're not imagining things, and there's a very clear reason why this happens.
The whole issue usually boils down to a single, simple concept, a bottleneck. And a bottleneck is just any point in a system where the flow of data gets choked up because of a single, slow component. This idea is really the core of the problem.
I mean, think of it like a traffic jam on the highway. It doesn't matter if your car can go 200 miles an hour on the open road. If you hit a one-lane construction zone, your entire trip slows to a crawl. Well, the exact same thing happens with data moving around inside your computer.
And here is the biggest traffic jam of them all. Your computer's processor, the CPU, is ridiculously fast. But the main memory, the RAM, where it has to go to get its instructions and data, it's often hundreds, literally hundreds of times slower. This huge speed gap creates a constant nagging bottleneck.
So how do engineers even begin to solve such a fundamental problem? Well, funny enough, they actually took a page from nature's playbook.
The solution is called caching, and the idea is just brilliant in its simplicity. Instead of forcing the super-fast CPU to always make that long, slow trip to main memory, engineers put a small, ultra-fast little bit of memory right next to it. And this cache holds copies of the data the CPU is most likely to need next.
You know, the concept is exactly like a squirrel getting ready for winter. It doesn't run all the way back to some distant oak tree every time it wants a single acorn. No way. It creates a little stash, a cache, right nearby its nest for quick and easy access. Your computer is doing the exact same thing, just with data instead of acorns.
Okay, so now let's dive into the most important cache in your entire system, the one that's built directly into the brain of the computer itself.
The CPU cache's entire reason for existing is to be that squirrel stash. It sits right in between the lightning-fast processor and that much slower main memory, the RAM. And by trying to predict and store the right data, it ensures the CPU, hopefully, never has to wait around for what it needs.
But here's the cool part. It's not just one cache, it's a whole hierarchy of them. First, the CPU checks the level 1, or L1 cache. It's incredibly fast, but tiny. If the data isn't there, it checks the slightly larger and slightly slower L2 cache. Still no luck? Okay, then it checks the even bigger L3 cache before finally giving up and making that long, slow journey all the way out to main memory.
So as you can see, there's a really clear trade-off happening at each level. As you go from L1 down to L3, the cache gets a lot bigger, but it also gets a bit slower and farther away from the CPU's core. It's this clever balancing act, all designed to get the most critical data to the CPU as fast as humanly possible.
So every time the CPU needs a piece of data, one of two things happens. The best case scenario is what we call a cache hit. The data is right there in the cache, work continues instantly, everybody's happy. But the other outcome, a cache miss, well, that's a total performance killer. And this is the part that really matters. When a cache miss happens, the CPU literally stalls. It just stops everything and waits. And that waiting is incredibly expensive. In the time it takes to go get one piece of data from main memory, a modern CPU could have performed hundreds of other calculations. That's the lag you actually feel.
Now, the CPU cache is absolutely critical. But this clever idea, using a small, fast storage area to speed up access to a bigger, slower one, is used all over your computer. It's everywhere once you start looking for it.
Caches pretty much act as high-speed middlemen between almost all the major components. You'll find caches sitting between the CPU and RAM, between RAM and your hard drive, and even between your computer and the entire internet. A perfect example of this is the page cache. Your operating system is smart. It uses any leftover idle RAM you have as a cache for your much slower hard drive or SSD. And that is exactly why reopening a program or a big file is often almost instantaneous the second time you do it. You experience this literally every single day with your web browser. Your browser saves things like images, logos, and bits of code from websites you visit into a local cache. So, when you go back to that site, the page just pops up instantly because it's pulling most of the heavy stuff from your fast local drive instead of re-downloading it all over the slow internet. Okay, so we've covered what caching is and where it's used. Now let's bring it all home and talk about why this actually matters to you.
Really, there are three big takeaways here. First, Caching is the fundamental way engineers fight back against bottlenecks. Second, when you're comparing CPUs, don't just look at clock speed. The amount of cache, especially L2 and L3, is a huge factor in real-world performance. And third, this whole thing explains why adding more RAM can make your entire computer feel faster. You're giving the operating system a bigger page cache to play with, which means fewer slow trips to the hard drive.
And all this leads to a really fascinating question about the future of computing. As our processors keep getting exponentially faster, that speed gap between them and our memory and storage just gets wider and wider. So maybe, just maybe, the next giant leap in performance won't come from just making CPUs faster, but from designing smarter, bigger, more predictive caching systems that make sure those powerful CPUs never ever have to wait.